For decades, astronomers have monitored Betelgeuse, recording variations in brightness, temperature, and atmospheric activity. Right-pointing arrow. These changes reveal that the star is far more dynamic and unstable than it appears as a steady reddish point of light in the constellation Orion. Right-pointing arrow located in Orion's shoulder. Betelgeuse has been observed for centuries due to its distinct red color and high brightness. Although it appears stable from Earth, it is actually a highly active red supergiant in a late stage of stellar evolution. Right-pointing arrow. At its core, nuclear fusion generates energy under extreme temperature and pressure, creating an outward radiation force that balances gravity. This equilibrium keeps the star stable for long periods, but in massive stars like Betelgeuse, the balance gradually weakens as fuel is exhausted. Right-pointing arrow. Having already burned most hydrogen, Betelgeuse now fuses heavier elements in layered shells around the core. These later fusion stages are unstable and create turbulence throughout the star. Right-pointing arrow. Its interior is dominated by huge convection currents, where superheated plasma rises and cooler material sinks. These massive convection cells reshape the outer layers and contribute to irregular brightness changes. Right-pointing arrow. Betelgeuse also undergoes large-scale pulsations, expanding and contracting in an uneven, unpredictable cycle. Shock waves generated inside the star travel outward and disturb its surface, further altering its luminosity. Right-pointing arrow. The star's surface is therefore not uniform but constantly changing due to interacting processes of convection, pulsation, radiation pressure, and gravity. Right-pointing arrow. One notable event, the Great Dimming, caused a sudden drop in brightness. It was later explained by a cloud of dust ejected from the star, not an imminent explosion. Right-pointing arrow. Betelgeuse lies roughly 640 to 700 light-years from Earth, meaning we observe it as it was centuries ago, not in real time. Right-pointing arrow. Despite being cooler than many stars, its enormous size allows it to emit vast amounts of energy. If placed at the center of our solar system, its outer layers could extend beyond Jupiter's orbit, engulfing the inner planets. Right-pointing arrow. The star also produces strong stellar winds that eject gas and dust into space, enriching surrounding regions with elements that later form new stars and planets. Right-pointing arrow. Eventually, Betelgeuse will exhaust its fuel completely, leading to a core collapse supernova. This explosion will briefly make it extremely bright, possibly visible even in daylight. Right-pointing arrow. Although dramatic, this event poses no threat to Earth due to the star's distance. Instead, it will provide scientists with a rare opportunity to study stellar death in real time. Right-pointing arrow. In the end, Betelgeuse represents the life cycle of massive stars: formation, instability, and eventual explosive renewal that recycles elements back into the universe.